All right, welcome to Module 2. In this module, we're going to provide an introduction to neuroanatomy. So we're going to provide an overview of basic neuroanatomy and neurophysiology, which just means the anatomy of the brain, understanding the different brain regions, and the physiology of the brain, understanding how these different regions work. By the end of this module, you should be able to understand how different brain structures and systems contribute to different psychobiological states, both in general and states specific to psychedelic research. So, sensation, perception, emotion, cognition, learning, and consciousness. We're going to build a familiarity with the different terminology and concepts that are central to the neuroscience of psychedelics so that you can have this kind of scaffolding to build on. We're going to explore a little bit of how psychedelic interventions interact with the brain and its different structures, systems, and states. And then, of course, we'll get into that in much more depth towards the second half of the class. And we're going to discuss other interventions that can also interact with the brain similarly to psychedelics. Things like meditation, mindfulness, exercise, nutrition, novelty, exploring, things like that, so that you really understand all of the tools in the tool belt. So you might be starting to feel a little bit intimidated and start to think, well, I didn't sign up for a neurobiology class. I signed up for a science of psychedelics class. And so we're going to start with a little lecture that is kind of designed just to help keep things pretty simple, pretty palatable. And I'm going to tell you about how I was taught to tell stories in science. And I'm going to do this using DreamWorks film Trolls. So Trolls, if for those of you who have watched it, if you haven't, this lesson might be a little rough going, but hang in there. Let me know. Please give me feedback on how it is if you haven't seen it. Trolls starts out as a story. And parallel to that, as researchers, as scientists, a lot of our career and what we do really depends on our ability to be good communicators and good storytellers. We need to be able to take these findings, this research, this work that we are so engrossed with, and share it with others and help them understand why we think it's so interesting and why they should care. So, the way that I usually do that in science is just the same. The way that I was taught to do it is the same way that we see this done in storytelling through the ages, right? And we're going to use trolls as an example. So, we start with the landscape. For those of you who have seen Trolls, it starts once upon a time in a happy forest, in the happiest tree, lived the happiest creatures the world has ever known, the trolls. They loved nothing more than to sing and dance and hug and sing and dance and sing and hug and hug and dance and sing, blah, 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 right? And it gets really fast. So, in this introduction, what they're doing is they're providing us an introduction to the landscape that this story is going to take place in the happy forest, in the happiest of trees, right? And then they're also giving us a little bit of an introduction into some of the main characters, and they're focusing more on the protagonists, the good guys, right? And so there's the trolls. They're the happiest creatures that the world has ever known. They love nothing more than to sing and dance. So they're saying, here's the trolls, here's a little bit about them. We're going to do this in this module as well. We're going to provide you with just a little introduction of the natural landscape of the brain, which is the landscape that most psychedelic interventions occur in and take place in, although they do also take place in other parts of the body and metaphysical realms as well. But we're going to focus on the brain as the natural landscape here. And we're going to introduce some of the neuroanatomy, so different brain regions that are kind of more key players in psychedelic actions. And then we're also going to focus on some of the different neurotransmitter systems that are kind of our protagonists in the story of the science of psychedelics. So these are the main characters, if you will. So, storytelling in science, we start by introducing the natural state of things, right? So, in Trolls, there's the natural landscape. It's the happy forest, the happy brain would be the equivalent in neuroanatomy, and then the key characters. So, the trolls, or in the brain, the neurotransmitters and the brain regions. Then we introduce the potential for conflict, right? All good stories have conflict. They have intrigue. There's an antagonist. There's a potential for the whole natural state to become disrupted, right? And so in Trolls, that's the Bergens. And the movie Trolls goes on, but then one day the trolls were discovered by a Bergen. The Bergens didn't know how to sing or dance or even hug. They were the most miserable creatures in all the land. And once they saw how happy the trolls were, they wanted some of that happiness for themselves. So the Bergens are our antagonists. They are the potential to disrupt the system. And so there's this kind of introduction of threat. And so, what does that look like in the brain? In the brain, when we're exposed to stressors, the body initiates this response. So here we're seeing a spider that might be the equivalent of a Bergen, right? It has a potential to disrupt the system. If we get bitten by it, it's poisonous. And we actually have some of our own adaptations in the brain that respond to that, right? So when we see a spider, we take that sensory information in with our eyes. Oops, and it kind of goes into our brain, but we'll talk a little bit more about that. Here, we're just focusing on there's a potential for the system to be disrupted. Now, in the movie, the trolls get captured, but resilience presides. King Peppy leads the trolls to escape. So the trolls have ways to keep the Bergens at bay or to escape them, right? So King Peppy leads their escape, demonstrating resilience and resourcefulness. Similarly, the brain has its own built-in systems to regulate these threats and respond to them appropriately. So in the brain, we see that spider, we take that stimuli in with our eyes, that goes into a part of the thalamus, the visual thalamus, then back to the visual cortex, and then to a part of the brain called the amygdala. Now, the amygdala is really associated with storing memories of threatening or aversive stimuli and experiences. So, how do we know that a spider is bad for us? Part of that involves our amygdala. It rings alarm bells in our brain. When the amygdala gets activated, a few things happen. It kicks off this stress response. So it signals to a brain region called the hypothalamus. This here is the human brain we're looking at here. That might be hard to tell. So it activates the hypothalamus, which secretes these hormones, CRF, and that activates the pituitary, which is also in the brain. The pituitary secretes more hormones, ACTH, which are glucocorticoids. So they're kind of stress hormones on their own. But the big thing that ACTH does is that it stimulates the adrenal glands. Now, the adrenal glands are in the body, they sit on top of our kidneys bilaterally. One really cool thing about hormones like CRF, ACTH, as well as cortisol, which you're kind of seeing here, is they're lipophilic, which is a fancy word. They're steroids, they're lipophilic, which just means that they can cross barriers. So, for example, CRF can be secreted in the hypothalamus, but it can cross the blood-brain barrier to act in the body. ACTH, secreted by the pituitary, can go off into the blood and again get all the way down to the adrenals to act on the adrenal cortex. When the adrenal cortex is stimulated by ACTH, it secretes cortisol, which is our primary stress hormone. It's a glucocorticoid. It's also a steroid and lipophilic, which means that when it's secreted into the blood, it has all of these effects that go throughout the entire body, but it can also cross the blood-brain barrier to act in the brain as neurotransmitters, which it does. Now, there are a few regions in the brain that are particularly sensitive to stress hormones like cortisol. They have a really high expression of receptors. Two regions that we'll focus on right now are the hippocampus and the amygdala. The amygdala, you remember, we already talked about that's the one that responds to threatening stimuli. When glucocorticoids like cortisol hit the amygdala, it just activates and turns on this system. It ramps it up. So it causes us to secrete more stress hormones, as well as the adrenals also will secrete adrenaline and noradrenaline. So these are going to kind of kick in our fight, flight, or freeze response. They're going to help us respond to this threat. Eventually, as enough cortisol is secreted into the blood system, it's going to act on the hippocampus. Now, the hippocampus is involved in learning, memory. That's kind of the dorsal or the like back upper side of the hippocampus. It's also connected to all these other brain regions. It's involved in emotional responses to stress. But one really cool thing that it does is it evokes negative feedback onto this whole system. We call this system the HPA axis, stands for hypothalamus, pituitary, adrenal, the HPA axis that regulates neuroendocrine, so just brain, neuroendocrine hormone, so hormones that can act in the brain, stress responses. And when cortisol acts on receptors in the hippocampus, it kind of turns that system off. And it's a really self-preserving mechanism. We can't have the system staying on. We'll get overexposure to cortisol. That's not a good thing for tissues. I like to think of the hippocampus as kind of the rheostat or the thermostat for stress in the brain. So if you have a air conditioning in your house or a thermostat, you set it for a certain temperature, right? And then once the house reaches that temperature, it turns off. That's a negative feedback loop. Hippocampus does the same thing. So you see a threat, your amygdala responds, that turns on this stress system. And then when there's enough stress in the body, the hippocampus turns the system off. So that's kind of our stress system in a nutshell. That's our one of our main resilient safety and more, I would say, emergency mechanisms that we have to save us when we get into trouble. So here's the hippocampus turning that system off. And then again with the trolls, they had this escape mechanism, right? So King Peppy led the trolls to safety, where they then kind of remained hidden from the Bergens so that they could be safe. And resilience presides thanks to our stress response and our own innate resilience. But those of you who have watched Trolls know that this is not where the story ends. Okay, so we've covered the natural state of things, the happy forest, the happy brain. We've covered the potential for conflict, the risk for Bergen's, threat aversion, and we've even covered some of the ability to overcome conflict and maintain harmony. So the trolls can escape and stay hidden. We have our neuroendocrine stress system, our HPA axis, and these mechanisms that can help us respond to aversive stimuli, threats, and stress. But the story doesn't end there. So in Trolls, that's all just takes place in the first like 5 to 15 minutes, right? So what happens when this balance is lost, which we know it inevitably will be? In the movie Trolls, harmony is eventually lost. One fateful day, the Trolls village is discovered, and several trolls are captured by the Bergens. So the Bergens take over. This is kind of the equivalent of what can happen when stress takes hold in the body. So, here we go. Okay, they're captured. Okay, so this is kind of the equivalent of what can happen when stress takes hold in the body. Now, stress operates on kind of a Goldilocks or an inverted U-shaped curve, which you're seeing right here. So too little stress, and we're not going to have enough motivation to really do anything. We're going to be inactive. We're going to be, too laid back. We're not going to have motivation to get things done. Let me take a step back. Most people think of stress as being a bad thing, right? It feels uncomfortable. Nobody likes to get stressed out. I do have to add the caveat here, stress actually does play a really important role in our lives, right? So if we have too little stress, as you can see here, we don't have really motivation to do much of anything. That stress can be a really good thing. When we start to get into optimal levels of stress, that's when we really see performance peak. But if we get too much stress, we'll start to get exhaustion. Our whole kind of adrenal hormone system can get dysregulated. Our brain can get dysregulated because the tissues aren't really, kind of made or they don't function optimally while they're being exposed to cortisol. It's kind of our emergency system. It's not meant to stay on all the time. And so when we have large amounts of stress or that system stays on for a long amount of time, that's when things can really get into this red zone here. We can get anxiety, panic, anger, breakdown, burnout, all of these types of symptoms. Here's a really good way to think of it. Stress is like our emergency system. It can save us once, right? And so a normal short-term stress response, we get the stressor and we bounce right back. But if we're exposed to repeated stress or chronic stress or really extreme stresses, or especially stress in childhood that is repeated or chronic or extreme, we kind of lose the ability to bounce back, right? It's like if you've ever jumped on a trampoline with another person, and sometimes you guys are in sync and it's great, you get this great double bounce, but sometimes you get out of sync and then you're not really bouncing at all. Things just get uncoordinated. It's the same thing when we get overexposure to stressor, we get this, our whole system becomes uncoordinated and it becomes no longer able to really adapt very well. So we've got the natural state of things, the potential for conflict, resilience, the ability to overcome conflict, but then balance gets lost. And then we have our rescue mission, right? I had a professor when I was in undergraduate who said, if it's not a happy ending, it's not the ending of the story yet. I think that's a great lesson in life, equally applicable here, right? So when balance is lost, that's not a happy ending, so that's not the ending of the story. So we have the rescue mission. And the rescue mission is going to be analogous to kind of therapy, right? So our optimist Poppy and our realist Branch transform Bridget. So enter Princess Poppy, the optimistic leader. She's teaming up with Branch, the cautious realist, to save their friends. And I use ChatGPT or Microsoft Copilot here to give me a little extra content, so I'll read it. This collaboration represents the diversity of interventions that support the brain's recovery. These include neuroplasticity. If you don't know what that is, don't worry about it. We'll touch on it in a second. The brain's ability to adapt and rewire itself. Alongside psychedelics, key interventions include social connection, rest, mindfulness, therapy, nutrition, exercise. I maybe jumped the gun a little bit in giving you that, so let's just kind of keep moving forward. So we've got our rescue mission. Here's Bridget. She's with the trolls. The trolls kind of get this idea to model for her what healing can look like, really, what self-care can look like, right? So we see Poppy kind of modeling for Bridget, like, hey, I'm doing this self-care thing. I'm into colors and spunkiness. I can share that with you, right? Now, there are numerous analogies here. This movie is just rife with really fantastic analogies for healing. So, the collaboration between Poppy and Branch really can represent the diversity of interventions, as I mentioned. Poppy also is very hopeful, very optimistic, very courageous. She really can be a representation of therapy and the things that we kind of really can help facilitate therapy. Some might even say that we need to be able to have healing and therapy. Poppy loves song and dance, so she also is just embodied in different healing modalities. We could add this as an analogy for psychedelic medicines. And then Branch, he's more of the realist, he's more pragmatic, he's more cautious. He kind of represents these kind of guardrails that we have in the in the science of psychedelics, in the psychedelic community, in the use of psychedelic medicines, right? He can also represent therapeutic integration. So we'll get into this much more in depth later in the class, but one way in which psychedelics act are that they can facilitate neurogenesis, so they can stimulate the birth of new brain cells, and they can enable brain cells to form new connections with one another. We call that kind of integration into the system. But if we're not intentional about that piece, there's also potential for psychedelics to just further ingrain cognitive patterns that already exist, right? So there is a real importance for caution. Branch can also represent the kind of underlying mechanisms or the neurobiology that are maybe a bit more set in their ways, right? And so we need that Poppy to come in and kind of break things up. So I mentioned neurogenesis. Now, here's kind of the brain equivalent of Poppy and Branch's rescue mission. In the brain, one of the main ways that psychedelics work are not maybe one of several ways that psychedelics work are that they can stimulate neurogenesis, which just means that they can stimulate the birth of new brain cells in the brain. So here we're seeing the human brain. We're seeing the cortex right here. If you don't know these terms, don't worry about it. We'll go over them. We're seeing the cortex. We're seeing the hippocampus. That's that brain region I mentioned is responsible for learning, memory, regulating stress responses, responding to stress responses, so mediating the way that stress impacts emotion or reward. And then this red ball here is the amygdala, which is that part that responds to aversive stimuli or threatful stimuli. These parts are highlighted, and then we're seeing the hypothalamus in there as well. These parts are highlighted because they're all known to have pretty robust neurogenesis that occurs throughout the lifespan. So, including when we're adults, we are still actively producing new baby brain cells every day in these brain regions. And so just wanted to show the timeline here. We've got a neural stem cell. It goes through this process of proliferation. We get these neuroprogenitor cells. If this doesn't mean anything to you, don't worry about it. At about 3 days, the cell starts to differentiate into a neuroblast and then eventually into an immature neuron once it hits this survival stage, and then a mature neuron. Now, that's to some of you, that might be kind of cool. To some of you, that might be kind of overwhelming. That's totally fine. One point I want to make right up front here is that process takes at a minimum a month, 4 weeks. Better estimates are around 2 months, I would say. Um, so we might start engaging in a healing modality, whether that's psychedelic therapies or meditation, mindfulness, exercise. It's going to take about a month for the neurobiological active mechanisms of that intervention to really take hold, right? So I also work as a health coach. I have this discussion with my clients that it might be about a month before you're really starting to feel changes kick in. Usually, when you start engaging in therapy, you're going to feel a lot of benefits right away, right? Like you're taking an action for yourself. There's hope in that. You're connecting with someone. You might be getting things off your chest. Maybe not, but maybe. But usually, it's going to take about when you're getting into the deep work of trying to establish different behavioral patterns, different cognitive patterns, things like this. It's going to take about a month just for your brain to produce new brain cells that are mature and then integrate them into the system or form new systems or new connections that can really support new cognitive processes and new behavioral processes. So the rescue mission, pinning this back to the analogy, neurogenesis is kind of at the heart of it, and neuroplasticity as well. So the ability for these brain cells to form new connections with one another. And it kind of represents that innate healing that we all have inside of us, and we can use a variety of therapeutic mechanisms to tap into. So here's a little zoom in case you couldn't see it well. I meant to come into this when I was giving the other. But again, so neurogenesis is kind of the process by which new brain cells or new brain heroes are born, right? And then again, just showing the timeline there. This one I wanted to show just because it's a little bit more accurate here. It's telling us 42 days, so about a month and a half to get a new neuron to maturity, and then can take another month to kind of integrate into a new system. Doesn't always take that long, but it can. So this healing transformation, right, where we're undergoing change and our brain is actually changing to support that. We're getting the maturation of mature brain cells integrated into a new system. Now, one thing I want to say, don't get too caught up on these terms, radial glial cell, intermediate progenitor. Those are only there if you're curious. You do not need to know those. Not a big deal. So we also in the movie Trolls, right? We see that Princess Bridget goes through this transformation. So Poppy kind of gives her this idea and they kind of run with it. And all of a sudden her hair is she's all getting glammed up, right? It's your typical, typical glam transformation movie. Um, so Optimus Poppy and Realist Branch help to transform Bridget. Let me see if there's anything else that I want to add there. No, I think we're good there. So, one point that I want to make here, and I kind of touched on the neurodiversity of neurogenic therapies. So, neurogenesis, that process of new brain cells being born and growing, that is really central to a lot of healing and therapeutic processes. And there are a lot of different things, different types of therapies that can stimulate that. And I do not have the citation for this publication on here. Shame, shame, shame on me, but I'll put it in the comments of this PowerPoint slide. But this is from a PubMed indexed publication. I promise. And they're just showing um, different interventions that can stimulate neurogenesis. Now, this is a rat brain that we're looking at here, and this is the hippocampus right here. It's just a figure of a rat brain. And on the right, we're also seeing different factors that can decrease neurogenesis. So stress, glucocorticoids like cortisol, age, opiate exposure, excitatory amino acids. So if we get overexcitation, all of these things can actually decrease neurogenesis. So they can prevent or slow the process of new brain cells being born and growing and developing in the brain. And there are actually a lot of important reasons for that. And we'll get into that a little bit later. I think that is important to know because just as I said, stress gets a bad rap. We tend to think of it as a bad thing, but it does serve a purpose. And there's kind of an underlying message that I really want to convey in this class of like, we have this really, really beautiful neuroanatomy and neurophysiology that has developed and stayed with us and evolved through centuries, so long, right? And a lot of it has been really conserved and preserved. It hasn't changed much, which indicates to us that it's really important. And so, when we're talking about using psychedelics or any intervention to really make changes, like lasting changes in the brain, in the body, in epigenetics, in the genome, I think it's really important that we have an understanding and a deep honoring and respect for the system that we're working in, right? For the landscape, for the body's innate ability to heal itself. Because there's also a very real risk with psychedelics, as there are with any interventions, of imposing too much onto the body, right? And we can impose risk when we're doing that. Even too much of a good thing can be a bad thing, right? So over here on the left, we're seeing interventions that can decrease neurogenesis, or over here on the right, over here on the left, we're seeing interventions that can increase neurogenesis. So this publication focused on exercise, enriched environments, and that can look like a lot of different ways to a lot of different people, maybe hanging art on the wall or going outside. Nature provides very, very enriched environments, just environments where there's a lot of stimuli, a lot of visual stimuli, a lot of sensory stimuli, and usually an element of safety and comfort as well. Hippocampal dependent learning. So we'll do, for the purposes right now, we'll just say learning anything. That can be learning a new skill. That can be learning how to do a handstand. That can be learning how to get to, a new location. So kind of map finding. Those are all different types of learning. Estrogen, just kind of by itself, can increase neurogenesis. In adolescence, all individuals, men and female, go through this huge hormone burst that includes estrogen as well as testosterone. One big impact of that is it stimulates neurogenesis that gives us kind of all these new brain cells that enable us to just learn become kind of sponges in adolescence, learn all these different things. Meditation, mindfulness, nutrition, dance, play, novelty, like anything new, social interaction, and then, of course, psychedelic interventions, these can all stimulate this process of neurogenesis, of new brain cells being born and growing in the brain. It's pretty cool. So there's really a diversity of neurogenic therapies. Okay, so back to storytelling in science. We've covered the natural state of things, the happy forest, the happy brain, the potential for conflict, the risk, the ability to overcome conflict and maintain harmony, our own innate resilience. We've talked about what happens when balance is lost, and we've talked about the rescue missions, so therapy, healing, kind of targeting neurogenesis. And we kind of covered a little bit of the healing transformation, right? So that's when we get this neurogenesis, new brain cells get born, and then they develop. In this analogy, if we're going back to trolls, Poppy and Branch can almost be symbolic of therapy itself or of the rescue mission itself. Poppy really embodies song, dance, therapy, healing, color. Branch embodies these cautiousness elements. And then Princess Bridget is really where we see the healing transformation, right? So we kind of see her change. And then there's another element of integration that is so important in psychedelic science. So once these brain cells reach maturity, they then get integrated into new brain or neural networks. We talk a lot in psychedelic science. We'll talk in this class about therapeutic integration, right? And that can be as simple as learning a new tool or a new skill in therapy and applying it to your life, whether that's setting a boundary or approaching a new situation differently or, having radical acceptance, and just kind of practicing that and integrating it into your life. In psychedelic science, there's also a very large neurobiological period of integration. When we're using neurogenic psychedelics and we're stimulating new brain cells to be born or grow or to form new connections, which we call synaptogenesis. In brain science, we call it a synapse. When two brain cells kind of connect to one another and talk to one another, because there's a little tiny space. We call that a synapse. I'll get into that more later. Um, when you're stimulating all of these processes, there's a period where things get integrated, where things are just really, they're really like malleable and plastic. There's high neuroplasticity, right? And so in psychedelic science, we want to be really intentional about that period. But that is a period that can make this kind of healing transformation become lasting, right? And so, Bridget doesn't just dress up once, she kind of changes her lifestyle and she incorporates that into her lifestyle, right? And there's another layer of healing integration in the movie Trolls because we see that Bridget's own self-healing spreads, right? So it goes from Bridget to the prince, and then pretty soon all of the Bergens are, in this technicolor, disco dancing, roller skating, super fun, healing energy and vibe, right? And so, again, the same is true of psychedelic actions in the brain. We might start with an intervention that could be psychedelics, again, that could be meditation, mindfulness, exercise that are going to target this neurogenesis or neuroplasticity and many other things in the brain. I'm just focusing on this one here. And that's going to give you like a one-time hit. And then, we have this integration process where those kind of healing mechanisms get integrated into the whole system, or those new brain cells get integrated into a new system. So we've got the healing transformation, the healing integration, and then, of course, we close it up with a bow. We've got the restoration back to harmony, to happiness, to the natural state, right? So we start once upon a time and we end, and they lived happily ever after. Um, and in Trolls, I think it's really beautiful. There's this lesson of healing at the end, and this is a quote from the movie, where Bridget identifies happiness isn't something that you put inside you like a troll. Eating happy trolls is not the solution to finding happiness. It's already there, right? And that's another really big kind of lesson that I hope to share with you in this class is that, you know, I've been working in neuroscience for over 10 years, probably over 15 years at this point. And one of the biggest things that I've learned is almost any intervention that you might engage in to stimulate healing, you already have that innate ability inside of yourself, right? So, psychedelics, for example, they can activate neurogenesis. We already have the ability to activate neurogenesis. And in fact, we're doing it all the time already, right? So, I think that's a really important message, especially for folks in this class who might be interested in kind of going on to pursue, psychedelic work, psychedelic assisted therapy, plant medicine work is these are tools to activate the innate healing that we already have inside ourselves and help restore us to our innate kind of way of being or harmony, right? So let's explore the brain's healing setup that's already there. This is the end of this lesson, and now we're going to move into our more kind of basic neuroanatomy lessons.